Hi, Sportster Paul. We're here with HSMWorks CAM program. We're going to do that test part we did in first impression, second, third impression as fast as we can. Should be about 25 minutes. Let's see if we can pull it off. Let's get up to SolidWorks. Here we are. I got the part saved. Rui HSMWorks. Rui's my buddy who made, Dave Rui, made this part purposely to trip up CAM systems. So let's see how it does. Go over here. This is the tab for HSMWorks. Say New Job. This is how I want it sitting in the vise, fixed jaw. So what do we got to do? We want a fixed size box because that's how you buy stock, everybody. Not relative. 4.5, 3.5, 1.5. Notice it changes right away. Great programming. There's centered on Z. No, we want to offset from the top 0.1. And so that puts most of the meat at the bottom for the vise to grab this thing and 1/10 of an inch on top to deck. I always have trouble with work 0. Gosh, I wish everybody do it like Visual Mill. Stock and orientation. The orientation is wrong because it's picked up the global. How did I fix that? Top center, front plane. How about use Z and Y? Is it up? Yeah, it's on top of the stock. Reverse the y-axis. Ah, that's right. Now I've learned you go here where it says top center and use the scroll wheel. And you can scroll around because there's 50 choices and you find the right one. There's the back corner on the fixed jaw of my vise. Okay, I think, okay, machine, undefined machine. We got our Avid, Benchtop Pro. Program name, let's just say top setup. I fear this is going to make separate files for each, but for now, that's good. Highlight it. Okay, part 0 is where we want, positive X to the right. Hold it down and say top setup. Okay, first thing we want to do, right click, new operation, 2D, face it. First thing, you got to pick a tool. I think I've learned how to do this. You can go like by type and say flat mill. You can scroll down, find a 1/4 inch flat mill because my little mill, this gantry mill, 1/4 inch flat, has aluminum over here. These are like redundant entries. I don't know what they're doing. It's goofy. But then say select, and I think that puts it in the part. That gets it from the library in the part. Now do it again, and here with it highlighted, say edit. And now we can do things so it doesn't crash. We need to make the overall length, let's go 3.5, not 35 inches. That's not going to work. 3.5. Here we make it 2.5. The flute length, let's make it 1.5. Crazy numbers. It's just going to keep from the side of the part won't fault out against this tool. 1/4 inch. Long. Okay. Say okay. Following. So it's given feeds or speeds. Let's let it override. I'm not sure what it would have changed anyway. So now we say select again, and we can see the picture of the tool is long. Like all the other programs, in the geometry here, select nothing. It's going to know to do all the stock instead of just like the top face. We want to go from the stock top to the model top. It guessed that right. Facing, it's taken pretty big whacks. I'd rather go 1/8 of an inch with this little mill. I'm not going for speed anymore. I'm going for accuracy. There's only 1/10 of an inch on top. Let's just try our luck and see what it says. There they are on top, 1/8 inch step overs. Double click, or not double click, hold click and say top, face, top, enter. Right click. Excuse me, new operation, 2D milling. Let's do a contour. We're going to do the perimeter of the part. Now, I love this program. It's kept the tool. So now where you select, we want to do the perimeter of it. So let's select here and hope that, yeah, that arrow means climb milling and all that other stuff is going to work. Tangent, yeah, we did want these checked. Nothing else special. We don't want to go from the stock top. We already decked it off. We want to go from the model top. The contour where we picked is how deep we want to go, but we want to go a little deeper. 0, minus 0.02. We want to go, we should see it hop down 20 thousandths. All right, and we should see it being about 20 thousandths down. It is. And that means it's going to undercut a little bit, so when we flip it over, it won't have a sharp edge. What's this? We want to go down. We got to go around twice. So we need to do 2 passes to get the corners of the stock. This has been all the programs had this problem. We want to go multiple depths. They use a tiny little default step down. Let's go here. We hardly ever do anything here in linking. Let's just take what we got. Okay, and it did a finish pass. I'm not sure I like that or not, but this is as fast as we can. We'll leave that extra finish pass in there. Double hold click and say perimeter. Click. Okay. Top setup. New operation. 2D milling. 2D pocket. Selects the tool from previous. Bless their heart. Now a SolidWorks function. Highlight the line. Oh, no. Take these off because it always, when software thinks, it always does the wrong thing. Select tangency there. Select tangency here. Add this line and this line. Did something wrong there? Yeah. There. Add this line. Now we're cooking. Then over here, there's a tiny little one you can skip easy there. There, and here. Okay, so that's a full perimeter now. A little hard to tell because of their color coding. Heights, let's see. We want to see always stock top. Why do they do that? Model top, and then we want to select how far we go. Where is it? From selection, right to here. So that's how, we only want to go to the top of this little island. All right. 2D pocket, let's see, passes. Step overs, pretty deep step over. Let's fine that up. Multiple depths, same thing, not 40 thousandths. 125. I don't think there's any, oh, take stock to leave. See, everybody wants to leave. All these programs love leaving stock. Like, oh, you want a rough? No, that's old thinking. I got a high-speed spindle. I just want to finish this. I think we're done. There they are. It's, you know, that linking that spirals in. You can mess with all that. We're just trying to get an overall flow. Hold it and say deep pocket. Enter. Come up here. New operation. 2D milling. 2D pocket. It's got the right tool. As it gets down deep. It did that perimeter. That's why it needed this long tool. Now, uncheck the help you, will think for you buttons. Do the start the same way with the select tangency. Then come here, here, here. I better slow up because when I rush like this, trying to, like it's a race, I make mistakes. Okay, now angle this a little and come back in. We want, oops, right, wrong. This one. Now watch this. Clever, my buddy Dave showed me this. The guy invented this part to test cam. It's not a real part. It's just something to confuse automatic feature recognition, which it confused on every single program that claims they can do automatic feature recognition. We're going to do this one. We're going to go here. Now we're going to go down. We're going to go across, and we'll go up. And that, as you can see, defines, it gets past this hole where the way you want it, and it deals with this little cusp and all of this cutout stuff. So that's done. Heights, now we got to go from, select. I'm rushing again. It's just going to cost me time in the end, like always, right? To selection, down to, I could get a face, but I like doing edges for some reason. So come on. So that looks good, right? We're just going to do that last bit. Here, the passes is a little fine, 125 I always like. Don't leave stock. Then there was multiple depths. This time I go down 1/10 of an inch because that'll be 2 passes, two depths, 2 step downs. I think we just do that. And there we are. To make sure we didn't leave stock, which we did because it should be going into that pocket. Let's shallow pocket, enter. Edit. I don't know what I did wrong. Come on, think. Stock to leave. So a little penalty. So now you can see it's gone in there. It's made, all of these radiuses are 0.26, so they're made for a tool to go in there. New operation, 2D milling, contour. This one's, because I practice, right, in the first impression, second, third impression, I know how to do this. 1/4 inch end mill, that's a genius of this part. Don't do any of this tangent nonsense. Don't help me. Just select that one. Arrows on the right side. Otherwise, you can reverse it. Go here. We want to go from, not stock top, we've machined that off, from model top. And to the contour, yes, we want to go as deep as that contour. Here, I always get, they put this goofy stuff in the beginning. Roughing passes. We want to go 125, and I'm pretty sure we want to do 8 of them. Multiple depths, we want to go down 1/8 of an inch. This is because my mill isn't, you know, a Haas or a Kitamura or anything super stiff. I think we're done. Let's see. Oops, no, we're not. So this is edit. I forgot my trick, which is make this 2.5 inches start longer, so it'll go all the way across, and separate them. This one doesn't have to be that big, just 0.1 is fine. And do it again. And now it's acting the way we want. Probably don't need 8, probably could take one of those passes off, but we're as fast as we can, right? Let's and do this, and this is the flat we are doing. Okay. Now up here, new operation, 3D milling. Parallel. Same tool. I used a ball mill going across. Dave showed me. No, you leave the same tool in here. He's a genius. Silhouette would be the whole part. Bounding box is the stock. Say selection. Select this and this. You don't want the tool scuffing these surfaces, so you get check surface here and here. I'm pretty sure I said contact point boundary. I'm not sure what I'm doing. I'm just poking stuff. From stock top to model bottom, that'll include, you know, it's only going to do these surfaces, I'm pretty sure. Instead of a pretty coarse step over, I went 20 thousandths, 0.02. Let's see. I think that's it. Let's see what it does. Yep, there they are. Beautiful. Beautiful. So that's the top. We're done. Come up here. New operation. No. New job. New job. Now this is the major flaw in many of these programs other than Visual Mill. The model. Yeah, I haven't changed the part. See, they're acting like it's a whole different part. You've got to redefine the stock, which is a complete absurdity. Fixed size box. So you got to do all this over again. And of course, this comes first, so you're going to see me get all tied up and frustrated and upset and cost a bunch of time, which I could have rehearsed it 20 times and had a script to do this. But center on Z set, offset from Z, and the same thing. Okay, so now we've set it up exactly like the first, 1/10 of an inch up. But now we're going to flip, the part was like this, we're going to flip it over, and we want part 0. Oh, come on. We want part 0 to be on the part right here. So you'd think there'd be some logical way. I can't figure it out. It's obviously not stock. It's use model in orientation. So now at least it's on the model. I think this is cumulative, like it kind of remembers. Use Z-axis. There was something about find an origin in some of these. Origin. Selected point. Right there. Oh, good. Reverse Z-axis. Notice how the stock moved. It's at least by 1,000,000,000 to 1, I got X pointing in the right direction. And so now we got to go up. See, this is why it's a completely fraudulent. They need a concept called setup, different than job. So this now is, I think, 0.4, puts it in the right spot. This is poking with sticks. This is so pathetic. Now the stock is exactly like it was, which I shouldn't have to redefine it at all. So here's the top setup. Oh, come on. Here's the bottom setup. Here, bottom, I still don't know why it uses bold sometimes and not other times. That's another mystery. Okay, new operation, 2D milling, face. It forgot that we had a 1/4" flat end mill. It won't remember across jobs. That's typical programmers. Don't select anything. From stock top to model top. Okay, it knows that. I like a finer step over. Gosh forbid they say the word step over, and we want to go down 1/10 of an inch at a time. Let's go here. There they are. Now, it's trying to face the exact top of the stock, which is a mistake. So we do edit. We go to the depths tab, which I think is here. They call it heights. So it's from the stock top minus 0.1. And now when we say one of those should go away. So it's in meat all the time. Machining face, bottom. Okay, good. Now, oops, not there. You got to say new operation, drilling, drill. Library. I forget where I find this. I think it was in inch aluminum. There is a center drill, 1/4" center drill. Figure that's the collet that's in there already. So where are we? Oops, maybe here it is. Center drills. Center drill, select 1/4" center drill. Select. So now it looks like it's supposed to. The feeds and speeds, I'm not messing with any of that, right? The holes. I figure if it's in the vise, get the close ones first so you can watch it. And I'm pretty sure that it obeys like solid cam. It obeys the order you pick. Master cam doesn't. Pretty sad. So there's the holes. It does say optimize order, so I'm not sure if it's going to override. From hole top, that's where it's going to start. Don't let it think where the whole bottom is. It doesn't know, right? From hole top, where's hole top again? From hole top and go down 2/10 of an inch, 0.2. A lot of different programs, I've learned this misery. And then here, drill, wrap it out. That's what we want to do. Something's wrong. It's up in the air. And let's, while we're here, center drill. I'm not going to edit out the mistakes, right? That's silly. And we should be, what's this one? Not geometry, this should be heights. From model top, go down 2/10 of an inch. It's still up in the air by 1.5 miles. Okay. Edit. Feed height, retract 0.4, 0.2, feed height from model top, plus 2/10 of an inch. Yes. Here, come on. Okay, that's where the hole should start. Oh, no wonder. See, I forgot the minus sign. Typical, just like programming, right? Make one tiny mistake. Thanks for reminding me we can save. No, always a good idea. This has been stable. Visual mill is unstable. So let's do this trick. Control C, Control V. Oop, come on. Light it up. Control C, Control V. Come down here, long click. Now we're going to drill it. Enter. Close this up, close this up. These T1, T2, you can see them, that's an option. Tools, oh, the triangle of hell. Tools, cam, preferences, operation manager, show tool number, okay? So that's why mine's different than yours. Okay, so we've done this. We have a capitalization problem. Professional writer, you can tell. Drill, wrap it. Now we're going to edit. Obviously, we need a different tool. Let's go back to that aluminum. I'm pretty sure it's in here. Drill, it's a number 7. 7201. That's it. Select. The edges, that carried over because we did a cut and paste. Instead of -22, you go -44. Even though SolidWorks defines it as 0.38 because they go to the corner of the flank of the drill, not the tip. The CAM programs all seem to prefer going down to the tip. Here, rather than drilling out, let's do chip breaking, although it doesn't show in the simulation. That kind of bothers me. I think we're there. Yes. Now, Control-C, Control-V, close it up, and rename this to tap 1/4-20. Oops, 20. Enter. Edit this. So the holes are the same. The tool's going to be wrong. You got to know, don't look in it. You got to know taps are way down here, you know, because that screws you up more. More confusing. 1/4, 3/8, quarter. You got to make sure it's a 1/4-20 here because they got a 28, a 1/4-32. Never even heard of that one. There's the tap. There, the edges are pre-selected. We didn't. Don't go down as deep as the tip of the drill. You will break the tap off. I've learned 0.38. Matter of fact, let's do 0.37 to make a point at the end. Then this is important. Don't do that. You have to say, I say right tapping. You probably could say just plain tapping. Boom. 21 minutes and 22 seconds. We're done. So faster than SolidCam, but I'm pretty well practiced in this. So now let's do stock simulation. We'll go here and say, okay, do the facing. Bam. Do the deep pocket. Or no, do the perimeter. Now, oops, I don't know what I just did there. Show the tool. Do the deep pocket. And we can see, you know, it's just gone down to that surface. Do the shallow pocket. Okay, let's finish that off. Look how beautiful. Different colors for everything. Now do the flat. Okay, and if you want, we can watch it do this, which I kind of like doing. It might be kind of hard on the tool, but this is the way I've done the other ones, you know. This one, like Mastercam, is perfect. It doesn't leave a little bit of stock on the edge here. So it's a little bit smarter than your average. I think I might, if I knew stuff better. Now it's doing the bottom facing. We can pause it and just shoot ahead. There it is faced. And now we can slow it down even a little more. There's a center drill. See, it's going in almost 0.2 of an inch. I'm not saying this is the right way to machine it. There's a drill. See, I don't see it pecking. Right? I just see it going in. I'd feel better if it pecked. Next should be the tap. There it is, 1/4-20 tap. And we remember it was, I had 3/8 in the final thing. I showed you how the Great Simulator, you get this showing up saying remove stock, no clashes, no problems. That's a good thing, right? Let's drag that off the screen. And then my evaluation for how good the program and how good the simulator is being able to go here and say, without even doing the compare function up here, right? To be able to go here and say, oh, the corner of the drill stopped right there. This 1/4-20 tap, which isn't modeled with a taper like SolidCam does, bless their heart, but it is modeled at 3/7, it stops just shy of the corner. So there's some room down here. You're not going to bottom out the tap in the cone of the drill tip. So fast as we can. What was it? 21 minutes? 22, call it? About a minute, 2 minutes faster than SolidCam. I can't remember. We might have done a simulation with SolidCam. Let's call it about the same as SolidCam. So this is my keeper. You know, I bought this program. I'm keeping it. Compare function. I don't think it's 20 shades of gray, right? You don't see anything going too wrong. They do leave a shaded area where there's an intentional gouge. In other words, the tap is 0.250 and the hole is 0.201 in virtue of the model. So they're just saying, well, it's not really a gouge. You know, we're not going to show that as a gouge. I don't think they do. No. And then what I do like about this compared to the simulator I like best, which is SolidCam, this one I'm getting to like because this distance function, you can hover over here, exact. Here it should, like if we go to those holes, I knew to do 0.44 from others, should be a tiny little error. Yeah, what is that, 3/10? Yeah, 3/10,000ths because of the math of a 118 point drill, and I didn't go 3 decimal places, right? Or I could probably get that perfect. So there it is. Fun, fun, fun. We'll do file, save. Once again, window, HSMWorks Fast. I'll post these up. I'll post this up on the article that I linked to in the description on the video. And that article will have the part files. And since I paid for this, the toolpaths will all show up. If you want to post it, you can post it, do stuff like that. So HSMWorks, fast as we can. Next, we're going to do the CamQuest, though it started this whole thing, CamQuest 2020. All the CAM programs I'm going to talk about that I evaluated, all the ones that work inside SolidWorks, other than other than Hypermill that didn't even want to give me a demo because I'm not good enough. I'm not Hypermill quality, I guess. All the pluses and minuses, why I bought HSMWorks, why I think the most capable is SolidCam, okay? Till then, we'll see you soon. Sportster Paul here. Good luck with your CAM journey. Bye now.